Hi everyone, welcome to the journey of maths with Sarah, a true lover of maths. I am back with one more video on inverse trigonometric functions, that is properties of inverse trigonometric functions. With the help of these properties we can find out the principal values very quickly and solve other problems too. Let us start the properties of inverse trigonometric functions. The first property is sine inverse 1 by x is equal to cosec inverse x. Then cos inverse 1 by x is equal to sec inverse x, and tan inverse 1 by x is equal to cot inverse x. Here x element of r minus 1 to 1. Here also x element of r minus 1 to 1, and here x greater than 0. You have learned reciprocal functions. You have learned reciprocal functions in class 10. What are the reciprocal functions? Sine and cosec, isn't it? Cos and sec, tan and cot. Here look at these functions, how they are related. Sine inverse 1 by x is equal to cosec inverse x, cos inverse 1 by x is equal to sec inverse x, and tan inverse 1 by x is equal to cot inverse x. We will prove one of them, rest we will understand. For that, first cosec inverse x is equal to y. Let cosec inverse x is equal to y, then we know x is equal to cosec y, or taking reciprocals on both sides, we get 1 by x is equal to 1 by cosec y. 1 by cosec y is nothing but sin y, isn't it? 1 by cosec y can be written as sin y. That is 1 by x is equal to sin y. Taking inverses on both sides, we get sin inverse 1 by x is equal to y. What is y? Cosec inverse x. So we can write sin inverse 1 by x is equal to cosec inverse x. Similarly, we can prove the other two results also. Cos inverse 1 by x is equal to sec inverse x, and tan inverse 1 by x is equal to cot inverse x. Suppose we want to find the value of cosec inverse 2. If you know the value directly, you can write it directly. Otherwise, you can write it as sin inverse 1 by 2. What is sin inverse 1 by 2? Sin 30. That is pi by 6. It has other uses too. I am just writing one of its uses. Cosec inverse 2 is nothing but sin inverse half. What is sin inverse half? Pi by 6. So we can write the answers directly. Sin inverse minus x is equal to minus sin inverse x. Tan inverse minus x is equal to minus tan inverse x, and cosec inverse minus x is equal to minus cosec inverse x. Here the x element of minus 1 to 1, here x greater than 0, and here x element of r minus 1 to 1. Write the domains here. Okay. So sin inverse minus x is equal to minus sin inverse x. How can we prove that? Take sin inverse minus x as y. Then we can write minus x as sin y, isn't it? That means x is equal to minus sin y, multiplying both sides using minus 1. Sin of minus theta is minus sin theta. So we can write it as sin of minus y. Reason, sin of minus theta is minus sin theta. So we can write minus sin theta as sin of minus y. Now taking inverses on both sides, we get sin inverse x is equal to minus y. What is y? Y is minus sin inverse minus x. Okay, again multiplying both sides using minus 1, we get sin inverse minus x is equal to minus sin inverse x. Sin inverse minus x is equal to minus sin inverse x. Similarly, we can prove tan inverse minus x is equal to minus tan inverse x, and cosec inverse minus x is equal to cosec inverse x. This 3 comes under the same group. What is the use of it? Suppose sin inverse minus 1 by 2. Find the principal value of sin inverse minus 1 by 2. The actual process you know. You have to proceed it like this. The whole steps we have to proceed. Instead of that, we can write it as minus sin inverse half. We know the value of sin inverse half, sin 30, isn't it? So we can write it as minus pi by 6 directly with the help of this property. Is it clear? One more question. Tan inverse minus root 3. Okay. According to the property, we can write it as minus tan inverse root 3. We can write the answer directly. What is tan inverse root 3? Tan 60, isn't it? So we can write it as minus pi by 3 directly with the help of this property. Now next set of properties. Property number 3. Cos inverse minus x is equal to pi minus cos inverse x. Second one, cot inverse minus x is equal to pi minus cot inverse x. And third one, sec inverse minus x is equal to pi minus sec inverse x. Okay, here x element of, write the domains here, minus 1 to 1, here x element of r, and here x element of r minus minus 1 to 1. Under this domains, cos inverse minus x is equal to pi minus cos inverse x, cot inverse minus x is equal to pi minus cot inverse x, and sec inverse minus x is equal to pi minus sec inverse x. We will prove one of them again. First one, let cos inverse minus x is equal to 1. So we can write minus x as cos y, isn't it? That is, x is equal to minus cos y, multiplying both sides using minus 1. This is not equal to cos of minus y. Why? Because cos of minus theta is cos theta, not minus cos theta. So how can we write? We can write it as cos of pi minus y, because cos 180 minus theta is minus cos theta. So x is equal to cos of pi minus y. Now taking inverses on both sides, we get cos inverse x is equal to pi minus y. What is y? Cos inverse minus x. So we can write it as pi minus cos inverse minus x. Interchanging the places or rearranging the places, we get cos inverse minus x is equal to pi minus cos inverse x. Similarly, we can prove the remaining two properties. Now, what is its application? Suppose we want to find the principal value of cos inverse minus half. Actual process you know, it's a lengthy one. Instead of that, we can write directly with the help of properties. That is, we can write it as pi minus cos inverse half. We know what is cos inverse half. Cos 60, that is pi minus 60 can be written as pi by 3. Pi minus pi by 3 is 2 pi by 3. There is no need of lengthy process. We can write it directly. One more. Cot inverse minus 1. Okay. We can write it as pi minus cot inverse 1. We know what is cot inverse 1? Pi by 4. That means pi minus pi by 4, that is equal to 3 pi by 4. Instead of lengthy process, we can write the values directly with the help of these properties. Now, next set of properties. Sin inverse x plus cos inverse x is equal to pi by 2. Second, sec inverse x plus cosec inverse x is equal to pi by 2. Third, tan inverse x plus cot inverse cot inverse x is equal to pi by 2, where x element of minus 1 to 1, here x element of r minus 1 to 1, write the domains here x element of r. We will prove one of them, that is sin inverse x plus cos inverse x is equal to pi by 2. Let sin inverse x is equal to y, then we can write x as sin y, isn't it? This is the same as cos pi by 2 minus y. Why? Cos pi by 2 minus theta is equal to sin theta. So sin theta can be written as cos pi by 2 minus y. Now taking inverses on both sides, we get cos inverse x is equal to pi by 2 minus y. What is y? Sin inverse x. So this is pi by 2 minus sin inverse x, or we get the answer as sin inverse x plus cos inverse x is equal to pi by 2. Similarly, we can prove the other results too. Okay, we will practice some questions related to the properties of inverse trigonometric functions. First, find the value of tan inverse 1 plus cos inverse minus half plus sin inverse minus half. We can solve it in any way. First question, tan inverse 1. What is tan inverse 1? Tan inverse 1 is pi by 4. Cos inverse minus half. Cos inverse minus half is nothing but pi minus cos inverse half, isn't it? And sin inverse minus half is minus sin inverse half. We can take this two common. Why? We know cos inverse x plus sin inverse x is equal to pi by 2. We can solve it directly. So this is pi by 4 plus pi minus cos inverse half plus sin inverse half. Cos inverse half plus sin inverse half. This is equal to pi by 4 plus pi minus pi by 2. Why pi by 2? Cos inverse x plus sin inverse x. Both are same. Cos inverse x plus sin inverse x is nothing but pi by 2. So we can write the answer directly. So what is this? This is pi by 4 plus pi minus pi by 2 is pi by 2. So final answer is pi by 4 plus pi by 2 is 3 pi by 4. We can solve it using LCM also. Now look at the second question. Cot of tan inverse alpha plus cot inverse alpha. Look at this too. Both are alpha, remains the same. So tan inverse x plus cot inverse x is nothing but pi by 2. So we can write it as cot of pi by 2. What is cot pi by 2? Cot pi by 2 is equal to 0. Now look at the third question. Tan inverse root 3 minus cot inverse minus root 3. We can rewrite it as tan inverse root 3 minus, what is cot inverse minus x? Cot inverse minus x is nothing but pi minus cot inverse x. So we can write it as pi minus cot inverse root 3. Okay. Now open the bracket and group it also. Tan inverse root 3 minus of minus becomes plus cot inverse root 3 minus pi. This is nothing but pi by 2. This is nothing but pi by 2. Why? Because tan inverse root 3 plus cot inverse root 3. Tan inverse x plus cot inverse x is equal to pi by 2. Pi by 2 minus pi is nothing but minus pi by 2. Hope all of you are enjoying my classes. If you have any doubt regarding these questions, comment below. Thank you for watching my video. If you like my videos, like, share and subscribe it. I will be back with more videos. Bye till next video.